So hello, I'm Jan. I'm based in Brno, where I'm responsible for a team that's developing like the computational core of Kiwi, like the search engine, and that's mostly like that is anything that is algorithmically interesting or big data, like some sort of big data processing and that kind of stuff. So pretty much all the stuff that's is being written in C++, partially in Python, but that's just for the high-level things. And then now we are currently in the process of migrating some of the Python parts into Golang. So that's sort of background. And today I would like to tell you a little about bindings, and especially binding of C++ into Golang. Why would you do that, right? Like Golang is a pretty nice language. It's very nice to write in. Why would you, like on Earth, why would you use C++? Well, C++ is quite fast, and also it has a huge heritage. Like, while Golang has been flourishing in the past years, it's booming, the thing is booming all around the place, but still C++ has 30 years of heritage. Like that's a massive amount of time, and Golang is going to take a lot of time to catch up, if ever, in some areas. Because C++ is still being a standard for high-performance computing, machine learning. Like I mean the back-end parts of machine learning. I mean usually Python is the platform for machine learning people, but the internals are written in C++, and that's the way it's going to be, because like you need speed in that terms. And also it's mostly used by academics to write like complex computer science libraries for example graph algorithms and those things. So C++ is useful, but what if you would like to use some library for C++ because you can't find it, like a library for Golang for some specific task, and you see a library in C++, how to use it, right? So you have a couple of options. Option one is you write a microservice. You just take that part of your like workflow that you need to implement or compute in C++ and write a microservice around it and just send the task to the via network or something like that, and compute it on the C++ HTTP server or something like that. Well, that's cool, but it's kind of pain in the ass to do that, because writing HTTP servers in C++ it's better than it used to be, but still it's not like in Python or something on Golang. It adds additional complexity. Obviously, you need to deploy the stuff, and you add latencies, you add data transfers that could be potentially huge if you need to transfer a lot of data to that C++ library. But that's not going to fly if you need to transfer hundreds of gigabytes of data. And also, if you do this often, you will get a lot of microservices. And while microservices are great, having too many microservices it's way to hell, really. On so many levels, it's way to hell. The other option is you can rewrite the library into native Golang. Well, yeah, you can do that, but if the library is complex, you don't want to spend 2 years just rewriting it. And it's probably not going to be as fast anyway, because if it's some heavily optimized machine learning stuff, then no way. And the third option is you can bind it. You can make this beautiful goo between C++ and Golang and just glue it together, and link it together, which will bring you quite a lot of the goodies. You will eliminate latencies. You can basically get the bus limited data transfer, which is cool, and it's pretty effortless, I would say. Well, effortless. Well, it takes a little practice to get it right, but it's fairly easy. So that's the thing I'm going to talk about today, because I had a lot of experience with binding things together with languages, especially binding Python and C++, which is much more difficult than binding Golang and C++, and we used it quite a lot. We use it till this day, and I think it's done a lot of good. So I think in Golang it could also be potentially very useful. So here's the first example. I'd like to show you. It's very simplistic. We will use the Golang's CGO package. That's natively provided by Golang developers, and it can be only used to bind C, pure C, with Golang. We will create a very simple, C library that is going to contain one function, and the purpose of the function will be to sum an array. Very simple. The structure will be, as you can see over there. We will create a shared library we call libsummer. We will create a sum array object file and sum array header, and also we'll have folder, and in that we will have the Golang main file. Very simple. This is how the C is going to look like. I hope it's readable. We have the sum array function that takes size and pointer to an array. Pretty easy. And then it just iterates through all the elements and sums them, returns the sum. Easy. We just compile it together with GCC or something into the shared library. For that you need that, minus fpic, minus shared magic variables. Otherwise it's not going to fly. And yeah, that's all there is. Who understands C here? Let me just ask. Who has ever written? All right. Okay. It is pretty standard. So this should be pretty understandable. So we have a shared library now. We are able to sum the numbers in C. And now, how do we get it? How do we get the array into C? You can see here that I have very simple, again, Golang file that contains main function that creates arithmetic series pretty much. It just creates number from 0 to 4, I believe. Yeah, something like that. Yeah. That's unfortunate. I thought it's going to sum up to 10, and it's not, because I thought we are incrementing from 1, but that's fine. All right, nevertheless, the program just creates an array of size 5, array of integers, and then fills the array, and then it calls some C dot sum array magic something, and then that sum array, that's exactly the thing we implemented previously in the C. That's the function, the sum array. So how does it happen that we have suddenly it available in the Golang? Well, it's because of this magical, not clearly visible things over here, and those are the instructions you give to CGO how to glue these things together. What you first say is that you provide some C flags that tell the compiler how to compile the code, because it actually has to go through the header and compile it, at least evaluate it and see what symbols are there. So you can see that I'm using the -i, I'm modifying the include path to actually tell the compiler where the headers are to be found. And you can see that it's relative to the source there. That's some variable that is provided by the CGO, and it actually means where the file that you are compiling right now is located. So you can see that I'm moving from the source there one bit up, one folder up, where the header is located. So I need to do that. Also, I need to provide the anchor flags. So also, that's the same story. My shared library is located one folder up, and it's called libsummer C. And also, I'm including the header actually, because I need to tell the Golang that I want this header, and I want these functions from this header. And that's pretty much all there is. You just give it this, and then you call the function. You need to do some magic to actually tell Golang how to convert stuff. You need to tell Golang that he is supposed to convert the Golang uint to C uint, and also you need to provide a pointer to an array. That's how you provide. This is how you provide a pointer to an array to C. actually. So you take a pointer of the first element in an array, and then you just cast it somehow, like to pointer to C int. And that's Golang is going to understand that, and is going to pass it to C, and the C is going to interpret the array as array of integers, of 32-bit integers to be precise. And it's going to sum them and return something that is not 10, actually. So that's it. That's a minimalistic example. Maybe also some real-world example. I'm not going to bother you with the specific and the implementation of it because that would be very long. But this is something I did recently. I needed to do a graph partitioning inside of my Go application to actually optimize number of requests I'm sending to external API. That's a bit of a long show, like this is like a bit of a stretch, like how you get from there, from graph partitioning to number of requests optimization. But like, if you model it right, then you get this. And graph partitioning problem that's very computationally demanding, and it's all about you have some graph and you have nodes, and you want to split the nodes into buckets pretty much, the vertices. And and you want to do it so that you minimize the cut of the graph. It's pretty easy to like explain, but it's very hard to do, and you actually need you need the big guns. You need some very sophisticated libraries actually able to solve this problem. And Kahybe is a great library that's written in C++, but the problem is that it has a C++ interface. And if you remember correctly, I told you that you can use the CGO only with C. So I was faced with this problem. So what I did was I created a C interface to the C++ library, and it actually looked like this. So I had the C++ library, that was the Kahybe library, and then I've written my own C library that would sit on top of the C++ library. I linked the C++ library to my library, provided C headers to the Golang, and then linked this library into the Golang. Bit of a pain. I could obviously, like, what would be much better would be to just implement the C interface directly in there, but then you are mixing C++ with C, and it gets complicated, and then also you are implementing some stuff into a library that you are not maintaining, and it's better to just implement something on top of that. But this thing works. I needed just one function, so it was very easy to actually do, and the C++ interface was actually very much C-like, so I had no problems. I didn't have to even to do any conversions of arrays to vectors, stuff like that, so it was very easy. And this actually works. So this was a real production problem. And here is one alternative to the CGO I found recently. And that's C4Go package. And it's supposed to, I actually found out just very recently when I was preparing this talk, I was just Googling about binding C to Golang. And I found this. And it's supposed to automatically generate bindings for C in Go, and based on some, like, you provided the C interface, you provide a YAML manifest, and it's supposed to generate the bindings for you and generate probably Go files or something like that. I'm providing you just a reference. I didn't test it, but it looks very cool. It has a lot of stars on GitHub, you know, so it's absolutely guaranteed to work. Yeah, that's just for reference. All right, and that's probably all for me. That's all about bindings. And thank you for attention. And if you have any questions, please ask me what you want. Yes?
Did you try Sweep?
Sorry?
Did you try Sweep?
Sweep, what was that?
It's a framework to generate bindings
for between C and Golang. No, I didn't try it. I think a friend of mine referenced it to me, but
you can access directly to C++.
All right. I didn't find out that. Yeah. I wasn't really I wasn't in need of like such a big guns or something like that. Like I just needed, like when I encountered a problem with the C++, I was just, well, I need just this one function, so I just created an interface. But, yeah. Yes?
Suppose one of these C functions takes a lot of time to complete. Is there any way to give control back to other coroutines? Or is that thread locked executing the C function?
Actually, well, no, I don't think so. Like the thread that is actually executing, you have no way of giving up the control. So that thread is pretty much blocked. But like if you have other threads, then you are fine. It's like when you have at least like one more core, which you most of the time you should, I guess, have these days. Yes.
What is the main difficulties in linking? I mean, have you some situation when you give it up to linking because it was so hard, or it was introduced some problems during the run of the program and so on?
Can you repeat the first part of the question?
What's the main difficulties in binding Go and C?
Oh. Well, when you don't have C and you have C++, then that is difficult. But if the framework works, then it should be also easy. But like mainly when there is a problem with data type convergence, sort of, that there can be a problem. If you need a bit more sophisticated structures to pass on to C, then it can be a little tricky because you need to tell the C like how to interpret the data you created in Golang. And that because of alignment and stuff, that can be very, very messy, I guess. But you can actually bind, I think that you can bind structures from C to, you can bind something like structures to Golang from C, and then like fill these structures and then use them in Golang, I think. That should be technically possible. Like create an array of these structures and then, so the data problem, I think.
So usually problems in taking care of Go structures inside C than taking care about C structures inside Go.
Well, sort of both. Like you have the problem of how to send the data to C, like how to create it in Golang. Because like what you always can do is like have some data in the Golang, and then do like translation to data, the data representation for C. But that part you can double your memory this way, which could be a problem potentially. Like for us, it's problematic. Like most of the time, because we usually operate on like, I don't know, our processes usually take 100 gigabytes of RAM and more. So you don't want to duplicate memory a lot of the time.
I have a question. Is it possible to get a panic because of interpretation of C structures?
To get a what?
Panic, go back. Or it's
definitely. You can even get a segfault, I guess.
Okay.
So, yeah. Like, I mean, definitely on the, I think you can get some sort of a panic when you are calling the C functions. I'm not sure about it, but you can definitely get a segfault, which isn't pleasant. Yep.
And what's the tooling support like for, you showed that Go file with all the comments at the top, and then you just used C dot, and the function matched your C function.
Yes, like it's all mysteriously, magically embedded into that C dot.
Right, so that just handles it.
Sorry?
That just handles it, and you don't have to worry about it.
Pretty much.
Okay.
Pretty much. Well, you need to do import C.
Sure.
The C code just embeds that into. Yep.
So how do you build databases? You need to do it in the same architecture, like the other person's file.
You mean like when you want to target, for example, Windows and Linux, or?
Yeah.
Oh, I never done that.
Okay, so you just run Linux in Local with the same architecture?
Yeah. Well, we mostly run even on the same processors, everything. Pretty much, like mostly the same architecture. Well, the same architecture and mostly even the same processor. I can like tell you the exact type of the processor we're running most of the servers on. Yeah.
Yeah. Do you pay any attention to the fact that memory that you give from Go to the C basically not controlled by garbage collection? Because I've seen a lot when people start using CGO, and they, for example, like you showed in the example c.int. For example, if you use c.string, you are responsible for this memory, and so you have to free this string. And if you don't read like docs or comments, you discover this in when you have memory.
Yeah, so that's another problem.
Did you read docs at the beginning?
Well, no, absolutely not. At the beginning, absolutely not. Like, who reads docs, right? Yeah.
You don't have memory reads.
Not till this point. Like, I mean, in the bindings we use we had a lot of memory leaks in the Python C++ bindings, but that's I would say that's much more complex than just those CGO bindings. That's much more. That's like you actually see what the memory is doing there. Right? Like, that's quite explicit. But yeah, you have to be quite careful about the bindings, and especially about the memory, because you throw stuff around and it's easy to get lost. Yeah?
The library is always linked dynamically, so that's why you have to put in the same image that...
I did only the dynamic bindings, but I don't really see any reason why it shouldn't be possible to do statically. I think it should be done. Like you should be able to do it statically. Yeah, I think so. Because
you deploy it, like a shared library? You deploy it too, or?
Yeah, well, we use Dockers. We use Docker images, so we just don't have to pay too much attention to that. But like, I know that one of our teams is doing like just one whole, statically linked everything together app in Golang, and I think they need to actually incorporate that. So I would say so. I would say it's possible.
More questions?
To finish our line of people. Do you write tests for your code?
Well, obviously. I mean, obviously, yes.
And the question is, if you, for example, if you integrate the C code in the Go code, you write tests for both parts, or only prefer to write only Go code and not write C tests for this code who was integrated?
Well, like in the example I was showing, I just used the library, so I didn't test the library for obvious reasons because I have no idea what the library does inside.
With library, every library has a good test coverage.
Yeah.
But for example, if you will write a code from the script, will you write tests for both parts? Or for example, only for Go code?
No, definitely for both parts. It would be super stupid not to write for both parts. So we would write the tests for both, like for Golang, also for C or C++. But then we would also probably write some integration tests to test the integration of C and Golang. We actually do that in when we are binding the Python and C++. We do have like integration testing that they are actually testing whether it actually works, the binding, because in Python it can blow up in various ways. So it's quite necessary to test it. And also it's a very good idea to run the test with Volgrins to test for mem leaks and things like that, because it's very easy to get some with that. Oh yeah, you're going back first now.
Did you try like pprof, for example, to find that code? Do you get inside of it, or it's like a black box? Like,
You mean where we are able to profile the C code?
Yeah, when
you
profile the Golang program, what do you get?
Yeah, well, I didn't try profiling exactly the Golang and C bindings, but we do a lot of profiling of like Python C++ bindings, and then there are like totally able to see anything that's going on in C++. You also see what's going on in the Python, because the Python interpreter is written in C. So you see a lot of garbage for Python, and then you see your code. And I would argue that would be pretty much the same with C and Golang. So you should be able to see quite plainly the C, C++ code. And then I don't know whether the pperf is actually able to natively profile Golang, but it probably is, right? I usually use just the the regular embedded profiler for Golang, but I don't know what's it running underneath.
That's native Golang.
Yeah. Okay. But like, if even the pperf should be like, because Golang it's translated to assembly, right? So it should be probably see some. You should be able to even profile the assembly of Golang. I would say so, but I don't know whether you would be able to make too much sense of it. But my colleagues are. Usually they just look at the assembly and they're like, well, there is a for loop and there is this and there is a vector and something, and I'm like, all right. So I guess, yeah.
Thank you, Jan.
Yeah.